Bonjour, good evening, good afternoon, maybe good morning, depends where you are. Today, we are going to continue making our game. It's going well. We restarted yesterday. We went from our cool game to a cool, I guess, tech demo. It's not really a game at the moment. And we were focusing on navigation. So yesterday, we set up a bunch of stuff, a bunch of frameworky stuff, so that we can create areas. We can define them based on a collider. We can draw an environment. Hey, Coco. Good to see you, man. We can draw an environment using tiles, which is pretty sweet. I mean, that's pretty standard. But what's not standard is our area populates with navigation nodes based on the environment and scores them all based on which collidables are nearby. Which means, yeah, non-standard is cool. Which means we can do this. And it mostly works. We can have a bunch of guys. Okay, I'll be honest, I didn't expect them to break down at the entrance. What's this game even about? Well, that's still up in the air, isn't it? It's about a spaceship. I guess they did get depressed. I expected them to come out. I really expected them to come out. He's happy. He's living the dream. He's living the Uber dream. This guy, though, doesn't have a path. Why don't you have a path? Gonna help him out a bit. But that shouldn't have happened. And then those two shouldn't be blocked. Yeah, they're in storage. That's really interesting. Look, it does mostly work and it's very cool. Maybe it's an interaction between the two different thingamajigs. Yeah, it almost certainly is. But it should be working. It was literally working just before I started the stream. So what did I change? That should be there for sure. Shouldn't make a difference though. If we haven't initialized the environment, we can't do pathfinding. That is a reasonable statement. It must be this guy. They're not... Well, they're not finding a path. which is interesting. I think all I did was modify the area collider, which is a bit bizarre. This is okay though, because this leaps us right into what we're doing this stream, which is fixing these last navigation issues. It's interesting. It's very interesting. It's like let's have a look. What's going on here? You want to go here, presumably. Which has a clearance of 1.2. Whereas his clearance, I think, is 1.25. I think this guy... Why do you need 1.25 clearance? I feel like you don't. I feel like you need half of that. .25 clearance is crazy. Well, there's no denying that fixed it. Do I think it's the right solution? Could go either way. They just had two big whiskers, yeah. They all freak out once they reach the target point. So they're all trying to go to a given target point. This is the other thing we need to fix. They're all trying to reach a single point. So they all try and get there, and they obviously can't all be on the same point, so they freak the F out. Which is fine. Like if I move this guy away now. You can see they're all trying to reach this point and they can't. So they just try random shit. Then they end up blocking each other and getting caught in eternal loops. What do the colours mean on the nav points? You know, I was talking about clearance. The colour represents how much clearance they've got. So how wide something can be that passes through them. So these guys have got pretty low clearance. They've got 0.4. So you have to have a clearance of less than 0.4 to be able to pass through this guy. Which, I'll be honest, I feel like it should be 0.5, but whatever. 0.4 is acceptable. Whereas these guys in the middle have got much greater clearance. 1.4, which is half the width. Which is why, because his clearance is 1.4, right? He's saying, oh, like 1.4 is units, so each grid node is like 1. So that's saying basically 1.5. If you're less than 1.5 wide, you can fit through here. What that actually means is you can be 3 units wide and fit here. But actually, you have to be 2.8, so there has to be a little bit of a gap. Which is actually quite nice, because it means they're not going to cram themselves through hallways that they're like literally the perfect size for. which would probably not work nicely. So that's what the colours mean. That's why up here they're all green, because there's nothing to touch them. But you see they update as the robots move around, because it takes the robots into account as well when it's calculating the clearance. So it's pretty neat. So you love cramming yourself in perfectly sized holes. Well, these guys don't get to do it. So the only issue left really, well, there might be two. Let's see how that other issue from yesterday's holding up. We had another issue yesterday, which was if I do that, there's a hole, but they can't fit through the hole, which is mostly fine, but it does confuse them sometimes. But it might not anymore. But it also massively might. If there's a hole they can't fit through, they don't like it. They get really confused by it. And the reason for that is I have this. So when we do pathfinding, I do this optimal route stuff, where I say find the optimal route, which means look for the route to your point, but don't worry about whether you can fit through the gap or not, which is not ideal, honestly. But that's where the problem is there. Because the optimal route says, oh, you can go through this small hole. And then their real route goes, I can't go through. Make it worry about fitting through. Yeah, but that's the problem. Like, if I take this stuff out, then they worry about fitting through. But the reason we put this stuff in so now they won't consider that hole. But now they don't do any optimal route stuff, which means these guys, see how they're not moving anymore? They cannot find a path to the target because this guy's here. Which means they have to wait until he leaves the corridor. And then they'll go, oh, cool. We can actually do it now. See that? Make it like first and then second optimal route. What? What does that even mean, Coco? And therein lies the problem. Because in order to figure out the route, they... so each node has these things on it. Clearance. Clearance A and clearance B. And clearance A and clearance B define whether something is blocking the route. The reason we have to have two of them is because they can be blocking the route themselves. So we have to say, for a given node, who's blocking it, and then who's the next person blocking it. So for example, if we look here, you can see that clearance A is goon 2, which is this guy. So he's the closest guy to the node, which means clearance A is 0.6, which means you can fit through here as long as you're 0.6 or less. That's fine. But the problem with if you've just got clearance A is when goon 2 looks at this node, he goes, no, I can't make the optimal route account for clearance. That's the problem. That's very much the problem. Because you have to account for clearance, right? The reason the optimal mode works is, so if we move this guy forwards to here, right? At this point, these guys need to be able to figure out, I can get there optimally, but this guy's blocking the path. So it has to take into account clearance because there's a way to make it not consider robots when calculating clearance. Potentially, right? You could ignore... You could only account for the walls. You can only account for the walls when you do optimal. But then we probably won't want it to only account for walls. But you could definitely have it... let's have a look. So the way it currently works is when we do the optimal, when we do the optimal, we just say you don't have a collider and you've got no clearance, which is very much the problem. But what we'd really want to do is, so this has this is passable for. So a node is passable under these conditions. If you don't have a collider, the node is passable. That's just true because you don't collide with anything. So, you know, if your clearance is less than clearance A, you can pass through. Cool. If you're not thinner than clearance A, so you can't fit through, if clearance A is not you, then that means you just can't pass through, right? So the object that is causing the low clearance, if that object is not you, then you can't pass through. If it is you, check clearance B. So, the way we've been doing the optimal route currently is we've just been saying, calculate it as if you don't have a collider. Which is not ideal. So let's make a new function called is optimally passable for. We'll make a new one that just does the optimal path. And this will start off the same. If you don't have a collider, you can go through. But also, the second line is also true, right? If you can fit through, then you can fit through. That's just a given. But if you can't fit through clearance A, that's where it changes. So you want to say if clearance A, clearance collider A is a wall. 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 I should be able to get which layer he's in. Maybe it's in the game object. Layer. Does not equal wall is does not equal layers dot walls. That's why I added that. If it equals walls, return false. You can't fit through. Can't fit through. Otherwise, we need to do the same thing, right? So if clearance B is greater than clearance, return true. If clearance collider B layer is walls, return false. Otherwise, you're potentially Gucci. Hello, PJ. I don't think I quite believe in that function, but it might work. So then, in here, we can pass in check optimal. And for the optimal route, we're saying yes, check optimal. And we need to actually pass in our collider. and our clearance. And that means I need to change this to say, look, if you're not checking optimal, check optimal anyway. Which I know is a bit uncouth, but, you know, if you're not asking for an optimal route, check the optimal route anyway. I'm okay with that, sort of. I might move that logic out, but for now it's living in here. So then here, we need to say var passable equals false. We could do something a bit cleverer. Equals check optimal end node is optimally passable for. Otherwise, end node is passable for. Then we just say if you're not passable. And that don't do that. Don't do that to me. Don't do that. God damn it. I need to steal that same logic. Yoink. Guess we can call that end node passable. Find closest walkable node. I need to pass it in here as well. Current node. Myself. Size. I'm going to rename these. Uh-huh. Cool. Can't wait for Goon Squad to comprehend that the hole is too small for their fat asses. Yeah, I know, right? This is going to do that. And that needs to pass in check optimal. And then we need to do the same thing here. Is passable equals check optimal. Neighbor is optimally passable for my collider with my clearance. Otherwise, neighbor is passable for my collider, my clearance. Okay, so if they're in the closed set or they're not passable, there we go. And then the path follower, when he's saying, can I get my path to follow? We say, yeah, and you are not going for the optimal path. Is this going to work? I guess we'll see. Somewhere beyond the sea. Do. Fuck. How'd I end up liking Chants of Sanaa? It was good, man. I really enjoyed it. Why do they still think they can fit through there? Let's have a look. Why do they still think they can fit through there? On the optimal run. If you're not checking optimal, then check the optimal and set your endpoint based on the optimal. Then, if you're checking optimal, see how I said I wasn't happy with this function? No, I don't have the old optimal route on. Oh wait, no I don't. No. Because I'm passing in the collider and the clearance now. Which is the only thing that used to define whether or not it was doing optimal in the past. Now we explicitly say it. Hello T-Pose, welcome back. So, this function is wrong. It's wrong. That's the only possible cause. Clearance A, clearance B. So we check clearance A. If we can't fit through it, if it's a wall, we say, you're too fat. If it's not a wall, we check clearance B. If we can't fit through it, if it's a wall, we say, you're too fat. Otherwise, we say, yeah, you can probably fit through it. That seems good enough. Let's pause at the moment that second guy reaches it. You. Your clearance A is walls. It's pretty much always going to be walls. Which means this guy so clearance A has got 0.4, clearance B has got 1. He needs a clearance of 0.625. So he will not fit through clearance A, right? So he's going to come in here. He's going to go, I have a collider. I cannot fit through. Clearance A's layer is indeed the wall. Oh. Yeah, I get it. I get it. I was using the layer mask, not the actual layer, which makes a big difference. Now it might work. Do 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 do. Nice. They finally will not try and cram themselves through holes they don't fit through. That is relatively cool. What are the goons meant to represent? At the moment, they don't represent anything. At the moment, they're just an object with a mildly irregular collision mesh. That's all they represent at the moment. The sprite that we're using is our Medbot sprite from our previous version. But yeah, they don't actually represent anything currently. So that's problem 1 solved. Why do the no, not med boxes, man, med bots, med robots. And the reason they look like that is because they have eyes that go here. You don't understand, Coco. You didn't see the old version. You don't have the context. You don't have the cognitive capacity to believe. Trust me, the medbots are pretty cool. So problem A is solved. That's really nice. And I'm even gonna go so far as to say Coco's suggestions did mildly help. The only thing you saw of the old version was me inserting and uninserting a cremation bed. Yeah, see man, it evolved a lot since those days. It evolved a lot. It evolved a lot since those days. You're proud of being a rubber duck. Yeah. Let's just do a little bit more testing. Do 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 do. Let's mix things up a bit. I don't think they'll fit through 2 gaps either, so let's put a 2 gap in. That should be interesting for them. As long as I bring that down another square or 2. Maybe... No, that should be fine. What's next on the navigation bugs? The fact that at the end they don't settle down. Let's see... Oh, I need to nuke that. Right, they should have to go all the way around here. They shouldn't have any other option. Because they can't fit through that. As much as they might want to. Nice. But a smaller guy could fit through that. Pretty cool, right? Not really sure why he did that. Not sure why they're avoiding this spot like the plague. But fair enough. So this is the next issue. When they reach their destination, they freak the F out. But that's because I'm not actually telling them they've reached their destination. Or as close as they can possibly get to their destination. Can you guess why this guy's bouncing back and forth? It's a bit of a weird behavior, but I understand it. It's because of the optimal route, right? That sweet, sweet optimal route. When he gets here, it's weird that he's not drawing his path, but fair enough. When he gets here, he's trying to get here. And his optimal route is saying, why don't you just, like, go this way, right? And then his non-optimal route, which kicks in afterwards, but only does 3 layers, is going, go here. 1, 2, 3. And then the optimal route is saying go here, but his 3 layers are going, actually, you can't go that way. Why don't you go this way instead? So he's going back and forth, because the optimal route keeps changing its mind. Well, the optimal route doesn't, but the non-optimal route keeps changing its mind. So I think the solution to that is something that I was thinking about earlier, which is the ability to claim a node. So let's say you got 2 guys going for the same node. You have the first guy that reaches it goes, this node is mine. I've reached it. Then the other guys, their pathfinding can say, ignore claimed nodes. Treat claimed nodes as if they don't exist. And that should potentially work. So, claimed by. So it's not claimed by anyone initially. And it's not passable if claimed by. If it's claimed, if claimed by is not null, so someone's claimed it. if someone's claimed it and it wasn't you, you ain't passing through that node. You're just not. I'm sorry, but you're not allowed. And that's pretty cool. Is that true for the optimals as well? Certainly can be true for the optimals. There's no reason why it can't be true for the optimals. So then, the path follower just needs to say he needs to know when he's reached his target position, right? Let's just put it here for now. Distance to target equals what? There's a disconnect here. In that target position is actually the target grid position. But you might have an actual real position that is not a grid position. Because from the person's perspective, they don't care about the nodes, right? They just want to say, I want to go here. I want to go to this point. So really, target position should be a vector 2. And update target should just take a vector 2. Like, I want to go to this specific position. And then this get path to point needs to take the target position, which it converts to a grid position. So that should be fine. And that's cool. Let's just check that still works. It should do. It's always good to check. Looks like it's fine. Something very satisfying about watching these. They all ignore this node. Except the last guy, I guess. So that's cool. Still working. I'm actually going to commit that just in case everything we do now is mental. Which it could be. Updated. What have we done? We've updated the check optimal stuff. Updated optimal route checking to ignore everything except walls. Sure. And then everything else we've done is just kind of irrelevant. Cool. So then, now we want to, if distance to target, well, distance to target is this target position minus this position. Don't do this to me. In what world is minus ambiguous? You son of a bitch. Happy now? So then we've got the distance, which is actually that dot magnitude. If distance to target is less than 0.1, let's say, that means you're right up to it. We need to claim the node. We need to claim the node that is for the target. Hello, NY. NY says, as a person that doesn't know anything about coding, this stream is interesting to watch. Good, I'm glad. We need to know the node, right? Which I do have kicking about in Pathfinder. I have a function. Well, I sort of have a function. I could definitely make a function. Get node for point. So if you give it a point, you get which node it is. To do that, we just say point to grid position, and then we say environment nodes grid pos. That should be fine, unless if the environment is not initialized, which is a problem on the first frame of the game. Just return null. And also, if there isn't a node for that grid position, just return null. Cool. So now we can say, here's a point. Can I please have the node for that point? Hello, Brian. And then in here, we can say, if we're really close to our target, let's get the closest node by asking our Pathfinder for the node for our target position. And then we can say, we claim it with our collider. Cool. And we can also say, will this game be available on Windows 7? I like the idea that this game will be available. I don't even know how I would make this game available. But if it ever is available, it's almost guaranteed that I've got no answer to that question. Coco says, this game is nowhere being done. Thanks for the vote of confidence, Coco. So we've claimed the node. Now we are going to have to think about unclaiming the node. But I think we unclaim the node. So we need to store our claimed node, right? So if we've claimed a node, we need to keep track of which one we've claimed. Coco says, I will riot if you don't make this game available. You know, I probably could put it on Steam rather. Think about all the dog shit people put on Steam. I could totally put this on Steam. Yeah, so when we update our target point, so we say, look, we're going somewhere new, we can say, okay, if we have a claimed node, let's relinquish it. Steam is unavailable on Windows 7. Look, at some point you just have to say, stop living in the past. Next you'll have people saying, when you make this game available, can you make it work on Linux? No, if you use Linux to play games, go fuck yourself. Although I think the Steam thingy uses Linux, so the answer to that might have to be yes. I'm not a big fan of Linux. Anyway, that might work. Let's see what that does, eh? I think it's not going to work. When I make this game available, can I make it be available on Windows XP? Yeah, sure. Let's see what happens when they reach their destination. I expect it to go horribly wrong. Horribly, horribly wrong. But that's why we try shit out. My game doesn't have to work on the Steam handheld. It does. And it will. It definitely will. I've already figured out the input side of things. So it'll work with controllers or keyboard mouse. That's actually not that hard. And then it should just work by default. Right, he should have claimed that node, which means he... You sons of bitches. So the problem we have here is, yes, he's claimed that node. But they still want that node. They want it. They want it. They're eager for it. They're hungry for that node. And they can't get it, so they're freaking out. So what we really need to do for these guys is say, if you can't reach that node, form a leisurely queue. Form a queue. Q pachu. Coco says, I foresaw this, but did not know how to word it. Ah, yes. Truly, you were cursed with knowledge, Coco. They settled down eventually. Until this guy moves. And then it becomes a free-for-all. Pretty cool though. So ideally, they would understand that they cannot reach the target, so they should just chill the F out. But maybe I don't care enough about that. I feel like a queuing system would be good, so I probably should care. But how would I implement said queuing system? I would say, let's take a look at the nodes again. Maybe not a queue, but a pick the spot next closest. Yeah, that'd be good enough, right? You might get into some weird situations, but that'd be fine. Come on, guys. They don't behave nicely on this corridor. They always ignore that node, except the last guy who doesn't. But that's because these nodes don't have a wall backing them up. Right, so this node is claimed by nobody? You're trying to go to 4-4. Did he claim like a weird node or something? Why didn't he claim that node? Why didn't he claim that node? It implies that he never reached it, right? It implies he never reached it. Hmm. Never reached it, huh? That's interesting. Okay, let's simplify this so we don't have to watch them do that mad walk every time. And let's add a little log in here. Claiming node dot no wait close. Okay. Claiming node closest node dot grid position. Let's see if he even does that. It's going to be a mad dash now to the node, which is fine. He never claimed the node. Which kind of makes sense if you think about it. Yeah, It does kind of make sense. Let's set the target node. And at the point that we update our target, we can say target node equals Pathfinder get node for point target position. So now we have a target node. They're going, okay, we're trying to reach this node. And distance to target becomes target node transform position. Arguably, we don't care about that anymore. Oh, excuse me. Target node claimed by us. And then let's see what happens. I think we're creeping our way towards a solution. Which is fine. That is a lot of nulls. If you don't have a target node, don't do anything. Make target position nullable. If target position doesn't have a value, so you've said, I don't want to go anywhere. I've got no target position anymore. I don't care where I am. Well, the first thing we want to do is, if we're updating our target point, we always want to give up our claimed node if we have one. Always. Then we want to set our new target position. If we don't have a target position anymore, then we don't need to do anything. But we do want to set target node equals null. Because if we don't have a target position, we don't have a target node. So if we've reached here, then we do have a target position, which means get node for point. We can say value. And we recalculate the path. If we're recalculating the path, then should recalculate path if this target position equals null. Definitely not recalculating the path, because why would we? Which means here, this isn't strictly true, but we can certainly assume it's true. Right, we should at least not be getting these nulls everywhere, and maybe he'll actually claim his node now. Or they won't do anything. It's always an option. Goon 3. Where's the beef? You're rocking some of those floating point inaccuracies, huh? You don't have a target node. Oh, of course you don't. I can't rely on that. Can't do it. If target position is null, do nothing. Here, if we have a target position, which we do because we've reached this point, but we don't have a target node, then this is like not true very often, but it can be true. Target node equals get node for point, target position. Dot value. Da, 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 da. Maybe that's better. Could go either way. I think it's better. Do you guys have a target position? No. I see. This is the thing with Unity where sometimes stuff gets nuked. And I think because I made that nullable, I can no longer set it in the editor, which is incredibly annoying. But for now, I mean, we're never going to want to set that in the editor, so for now, we can just say uh, 440. That's our old target position. And that's fine, because we're never actually going to want to hard code their target position. We'll be setting it via other behavior, so. Don't be such jerks. If we still don't have a target node after trying to get one, let's bail out. But that shouldn't be the case, because we set target position to be 440. Then it comes into the update. It says, oh, we have a target position, but we don't have a target node. So let's get a target node. And if we don't have one, let's bail out. So I would expect at this point that we always have a target node, right? The only thing I can think they'd be screwing that up would be if the environment isn't set up. So at this point, Goon 3 doesn't have a target node. And yet, you definitely should. Let's see what the debug log tells us. You definitely should have a target position. You do. Which means this guy is not returning the correct node. Which is pretty uncool. Let's see what's going on here. We're giving it 4-4, which means 4-4 was like up here, right? So the thing I've changed is we've switched from target nodes to positions. You give it a position and it takes you to the closest node to that position. But I'm wondering if I should... No. I was wondering if I should make everything grid based. But I don't think we can do that because we want to use sweet, sweet physics. It's never... it's never hitting this. Which is weird. So the environment... okay. Suddenly it all makes sense. In this function, I'm saying if the environment is initialized, return null. Instead of if it's not initialized, return null. What a wally. No wonder it could never find any nodes. Did you claim your node? Yes. Cool. One step closer. So he's at least claiming his node now, which is a definite plus. So, he has a position. He says, I've reached my node. I'm going to claim the node. And that's relatively cool. What happens if... Oh, I stopped it. So he's claimed it. What happens if I move him out the way? What happens if I kill him? See how they still don't want to go? Where was he? Here. They still don't actually want to reach this node anymore, look. Which is fine, that's what we expect, that's what we want. If we move them all away, they're not going to try and go to... Shit, where is it? Okay, they might do now because I deleted him. Whoops. Deleting him was the wrong call. I should put a marker on this. Okay, so Goon 1 has claimed it now. Which is a little odd because he's miles away. Maybe he was there in the past? Okay, look, Goon 1, can you go over here? You two spread out a bit. Which one is the node? It's like... Yeah, it's 3 up from the edge. Okay. So these two had every opportunity to actually reach this node. And yet they chose not to. Which is cool. Think about queuing, right? Queue. Queuing is tricky to do because the people in the queue could be different sizes. Which really messes things up. I think I'm losing faith in the whole claiming nodes philosophy. I think I am. Let's I want to keep that. So the issue that's making me not happy with this current solution is... Let's delete them all except one guy, right? Let's really clear things up. We've got one guy. Uno Dudo. And we're going to clear up the environment. He's got nothing stopping him anymore. He can live his dream. So, he was trying to get here. He got here. Fair play to him. He did indeed get here. But that's not where he's actually trying to get. It's not where he's actually trying to get. Because if we look what we've told him to do, we've actually told him to go to 4-4. That's not node 4-4. That is position 4-4. And position 4-4 is here. So we've told him to go here. At least I think that's position 4-4. Yeah. So that is position 4-4. That is where he's trying to get. Mostly. So he's actually going to the closest node to where he wants to get. Which is here. Which is fine. But it's not accurate, is it? So he's using the navigation mesh for navigation. All is well in the world. Until he gets close enough that he actually wants to do something with the place that he's reached. I think we might need a use case for this. I think we might need a use case. Because maybe him going there is totally fine. Like maybe him going here is fine. Because he's trying to go here. But who really cares about that? Like if he's gonna, let's say he's gonna interact with something. As long as he gets close enough to interact with it, life is good. I don't think there's any world in which we can say you want to go to 4-4. You're going to use the navigation grid, and then you're going to go to 4-4. Hello, Swifty. Because if he uses the navigation grid, which gets him like here, or like here, it gets him here, but because he's using physics, he actually slides a bit, and he ends up like here. Once he's reached the node, the best we can do, literally the best we can do, is have him sit on the node, right? So if we account for sliding, if we account for everything else, the best we can do is he's sat on the node. But he doesn't want to be on the node. He wants to be here. At that point, there's nothing we can do about it. He's as close as he's ever going to get. So, basically what I'm saying is, keep doing what we're doing. Except, there's one minor caveat to that, which is the whole he slides past the node routine. Which is maybe fine. So the way he works currently is he goes off and he gets a path. Right? Let's take a look at how he works currently. So he started off and he wants to go here. Here is the node he wants to go to. So he gets a path to it. All is well. Then he has a path. His path has steps in it. And he does have a rigid body. So he moves along the path. So we say, what is the next node in your path? What direction do you need to go in order to reach that node? Let's apply some force to you to shunt you in that direction. That's fine. Then we update his rotation, which is fine. And then we say, if you're within 0.1 units of the node, remove it and go to your next one. Which is cool, mostly, until we reach the end. So that makes him smoothly, like, drift around corners and shit, which is cool. But we need him to actually, when he reaches the end, this is going to kick in. And he's going to not actually reach his node. He's going to give up. So we need to know if, well, we need the direction regardless. But here, we need to say if next node is target node. So if you've actually reached the target, we're going to be a lot less lenient on this stuff. A lot less lenient. So, we set how close he has to be, and if his final one is the target node, we're going to say, look, you got to be closer than that, man. I don't know if this is going to work, but whatever. That is pretty neat. And then we can probably move this check. Yoink. Into here. If next node is target node, claim the node. Tidies things up a little bit. We don't have to do that check every time. Check we were doing anyway. Now, I feel like he's just never going to reach that closeness. But let's see what happens. He kind of did, actually. Maybe we should try and have him slow down as he reaches it. He definitely made it closer this time. He's not far off, but he did that weird squiggle at the end, right? He spins around it. Not ideal. So, when we apply the movement, what if we get the distance? Yoink. We calculate the distance as soon as we have the next node. Then, we know which direction we want to go. What if we apply a modifier to the movement between 1 and 0 based on how close he is to the final node? Force modifier equals 1. So we pass in a force modifier. And then here we just need to say something. We need to say like force modifier. If we only care about this for the last node. If next node equals target node. In fact, I'm just going to store that. So we're doing it in many places. So is it the target node? Right. If it's the target node, we want to reduce the force modifier based on the distance. We know that the maximum distance between two nodes is like 1.44. So what if we just YOLO that and we say force modifier equals distance divided by 1.44. Let's just see what that does. I don't expect it to be good, but I want to see what it does. Okay, it turns out it was pretty good. He's like spot on, right? Well, not spot on, but pretty damn close. So that's fairly neat. Now, I'll grant you, we're only testing it for one guy, but that is definitely getting him pretty damn close to the node. That's probably the best we're going to manage. Let's just ruin his day a bit. You son of a bitch. Which one's your target node now? I always lose it. Oh, he can't reach it. He can't reach it because he can never fit in that gap. I know technically he can. But that gap has a clearance of 0.4. Well, 0.6. Which technically he's not allowed. Which works fine because it means he doesn't get caught on corners. But that's cool because what if you're sending him to a location that has a collider? You probably want to go to the closest point to it, right? So the reason he overshot this is because our calculation is always looking for how close he is to this, but he can never reach this, so the Pathfinder doesn't even give him that node. The Pathfinder goes, nah, 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 nah. You're going here. But his speed calculation, the force multiplier, is always at 1 because he's not near this. So it's shooting him past it. Which is cool, but it does make it quite interesting because does that mean... So someone has said to this Pathfinder, I want to go to this position. And the Pathfinder has said, okay, well, here's the closest you're going to get. Is the is the person who asked for that path okay with that answer? Is the question. Like, are they willing to update their new target position? I think they are. I think they have to be. I think they have to be. So if I say I want to go from here to here, then the Pathfinder's going to go, sorry, best I can do is here. And I think it's reasonable for me to then go, okay, that's my target point. So for that, I said I was going to move this optimal route stuff out of the Pathfinder. And I think that's true. I think I am going to do it. I don't think it belongs in there. Because it's follower specific. So we have a function here, recalculate path. And should recalculate path. And Yeah? Yeah. We need a use case. We really need a use case. But for now, basically, when we're recalculating the path, what we actually want to do is we want to say get path to point passing our collider, passing our clearance, and we'll say yes, get me the optimal path. The optimal path will tell us what the optimal endpoint is. So we can say our target node is not where we asked to go. Our target node is where the Pathfinder says the closest we can get is optimally. So for that, we say optimal path last or default. There might just be no route there. That's cool. Then we can say when we're calculating our actual path, actual path is this, but we're not going to the target position anymore. We're going to the target node. And that's not optimal. That gives us the actual path. And that's arguably fine. But we're actually not setting the current path to be the entire path because that causes all sorts of issues with like multiple guys going down the same corridor. So what we do is we say, when you're getting your actual path, not your optimal, but your actual, your current path is the first three nodes of the actual path. And then once it's done with those, it checks again. And that's why when we draw the path, it draws those small lines. And it means it'll try and follow the optimal path. Generally speaking. But it will use the actual path for navigating around dynamic obstacles that could be in the way. That's why we do it that way. So, I think this, getting the optimal path, that's the optimal path never changes. So I think we can just do that when we update our target point. Yeah? And we're going to the new target node. It's not the target node we asked for, but it is the best we're going to get under optimal circumstances. Which means now, I know that might not have made any sense, but trust me, it did in my head. Let's see what he does. Well, now he throws a bunch of null reference exceptions. That's just a given. But why? We have a target position. Oh, we don't have a... Okay. I took this out, but I think we needed it. Sure. It's a bit lame, but it should work. If we can get this behaving nice, then we can think about ways to clean it up. Right, we expect him to go to this point. Perfect. I mean, not perfect, but definitely perfect enough. He was 0.03 off and 0.02 off in the other direction. That's as good as we're going to get. And that kind of margin shouldn't matter. He didn't claim it. Which is a little annoying. Why didn't you claim it? Because I never told you to. That's fair. No, I did tell you to. Oh, he's not within the threshold. The threshold is too brutal. Let's make that 0.5. Although, I still don't know if I believe in the claiming stuff anymore. But the threshold was too brutal. I like that he's drifting. It's pretty cool. Look, dude, why didn't you claim it this time? Did he do something mad, like claim a different one? No. What is his target node? Yeah, it is that one. Okay, cool. Is he really never hitting that? I mean, honestly, a large part of me is going, fuck it, this navigation is good enough for now. Let's get a use case. Because it is pretty damn good. Yeah, he never claims it. Let's add another one. They can have a race. I mean, it's pretty heavily in favor of this guy, but let's see what happens. Kinda weird that he gave up on life for a sec. Kinda weird that he massively overshot it that time. Have you got a different node this time? That wouldn't make any sense, but why are you perfectly on this node? And you've claimed it. What? So that is his target node. What about this guy? Who's your target node? Same one. Yeah, that makes sense. What doesn't make sense is the only thing I changed was I added another guy, right? I added another guy. Previously, this was their target node, which makes sense. Why did adding a second guy move their target node up 2? It's a good question, isn't it? What have I got their initial point set to? 4-4. And 4-4 is here. I guess it's just RNG. I guess it's just RNG. It shouldn't be. It should be pretty deterministic, but that's the only explanation I can see. Yeah, that's fine. It's fine with 2, but because now if this guy was to vacate the node, there's a little tweaking needing doing there because the final node is claimed. So he should have changed his target node because the target is claimed. So he should have gone to a nearby node, but he didn't. But that's a separate issue. But if we add a third one, now's where it goes haywire. The first guy is totally fine. He'll be Gucci. He'll go there, he'll get there, he'll live the dream. That guy up at the top really freaked out, eh? So he goes to his node, totally fine. He waits here. This guy comes along. And they start acting a bit weird. I mean, they've actually normalized quite nicely, but that's due to chance more than anything. Still, there is the age-old question of, is it good enough? Mostly. It's definitely mostly good enough. I don't like that these guys don't wait patiently on a node. But if they haven't reached their target node, then it doesn't really matter. They can be a little bit chaotic whilst they wait for this guy to vacate the premises. So this guy vacates the premises. They immediately start dueling over it. I'll be right back. Let's see if they win, if any of them ever win. Okay, I am back. So I guess they just duke it out for eternity. When two goons go to war. That's awkward, isn't it? Now you could let one of them claim it before getting there. Maybe we let them claim it if it's inside their current steps. We don't want them to be able to claim it from a distance. But you know how Here, we're getting them an actual path. What if instead of claiming it when they reach it, they claim it when their actual path says they're within 3? Or 2? Or 1? So what if we say, if this current path any contains target node. Congratulations, you've earned the target node. Now you could say, but they might both have it. And that's just not possible, I think. I should add some safeguards, but I'm not going to. I think we're getting closer to... I mean, I don't know why these guys freak out for a sec. Why did he move? Why did you move? Well, he's claimed it. That's fine. Let's kill him. Claimed by Goon 2. Okay, maybe I should put the safeguards. I feel like I shouldn't need these, but... Because this is supposed to take into account claimed stuff, right? Optimally passable for says... If it's claimed and it's not claimed by you, then ignore it. And is passable for says the same thing. So even their optimal route, if someone has claimed the target node, their optimal route should ignore it and it should give them a new target node, which is not the optimal. Which doesn't seem to be happening, but maybe that safeguard will now make that happen. It is bizarre how they stop moving. It's like their optimal isn't kicking in. Why do you do that? It's like their optimal isn't optimizing ever since I moved it out. Which doesn't make a lot of sense, but it does explain why there's odd behavior going on. You know, it's almost as if this is never getting called. But it is getting called. Target node is 5, 5. And is claimed by Goon. Current path is 3, 5. What? Target node on the other guy is 5, 5. His target node should have updated. Well, is that true? No, it's not true. This might end up in some weird behavior. But you know what? Sometimes I've said that and it's been pretty good actually. So see, when I moved this out of the Pathfinder, it was a lot more complicated in the Pathfinder. I was saying get the optimal route. If there isn't an optimal route, if there is, only get the first 2. I'm doing the old only get the first 2 on the wrong thing. So we do need to get the optimal each time. So I think we can move this to here. And we actually want the real path to not go towards the target node. We want to go towards the temp target. And then we can just take the entire actual path. That's where the problems were. I think. Now they shouldn't do that jankiness when the guy fills up the hole. And they might actually be cool. He was a cheeky bastard. I mean, we're throwing a lot of enumerables errors, but that makes sense. Importantly, He didn't give up his spot once he'd reached it. He has claimed that node. He hasn't claimed that one. And he hasn't claimed that one. But maybe that's okay. I think all I need to do now is... You jerks. Claimed by missing. Okay. Well, we can fix that one error. If optimal path doesn't have any, just return. That fixes that one error. But what I don't massively get, which I think we can do an experiment to figure out, is why they're not re-evaluating their target node. I mean, this is maybe fine. They're not strictly queuing. The only reason this isn't fine is that when we kill this guy... Actually, here's a test. Let's move this guy away instead of killing him and see what they do. They shouldn't try and go there because it's been claimed. And yet they do. Oh, great. Which implies that this is not limiting them as much as it should. So in the Pathfinder, we say it's got to be find closest walkable node, right? We say, is the end node passable? Now, if someone else has a claim on the node, so I am Goon 2, and Goon 1 has claimed the node. Assume that. This should return, you can't reach the end node, and this should return, you can't reach the end node, because both of these would say, the end node is claimed by Goon 1, so you can't reach it. So it should go in here, and it should say, let's find the closest node that I can reach. And for that, we go in here, and we check all the nodes. And these should return it's not passable if it's claimed. Which means their endpoint should always be an unclaimed node. Always. That logic all combined means the endpoint should always be an unclaimed node. And yet, there's no denying that that's not what's happening. Well, it's sort of happening. He's trying to go there. He can never reach there. It's the same problem we had with the other ones, right? He can never reach there, but he's trying to reach there anyway. And then he is probably also trying to go to the same spot. Yeah. So they're both not trying to go here. They're trying to go here. Which I would expect their target node to then have updated to not be that one. In the same way that this guy is actually trying to go here. Because this is 4-4, which is where we're trying to send them. But this guy is clever enough, being ahead of the pack, to go, the closest one to 4-4 is this one. So he goes here. But then these guys are not clever enough to go, well, I guess I can go here. And I guess I can go here. Which is what we expect. It's what I expect. And the reason I expect it is why do I expect it? Because of find closest walkable node. So their optimal check should never give them this. And it won't give them this. So it should give them these. So close yet so far. That's like the last issue. Why is it not? Target node becomes the last step in your optimal path. But the optimal path should legitimately never contain these. Except I don't think that's true. Yeah, I get it. I get it. I totally get it. It's a bit awkward, but I get it. This guy goes here, right? Then this guy's clearance colliders become the wall and this guy. That's pretty cool. Then this guy comes along. And he tries to get his optimal path. And it tells him, oh, this one's fine. Because clearance collider A would be this guy. And clearance collider B would be potentially himself. Which means this comes in. And it says, well, it's not got any wall clearance stuff going on, so you're good. Which is actually fine. This might let us tidy this up quite a lot. Let's call that static clearance instead of wall clearance. And do we care about the collider? No. Which means I don't think we need clearance A and clearance B anymore. No, we do. We definitely do. But at this point, we need to say we only need to do this once. Let's create a new function for it. Yoink. Yoink. This might need changing, especially if we're only doing it once. Yoink. So we go through and we say, can I have all the hits to everything except debug area and node? And then we say if hits any attached rigid body is null. That means it's static. Then we want to do this. Minus that. Static clearance is that. And when we're doing the optimals, we don't need to do all this shit anymore. We do need to do the claimed, but we don't need to do all this shit. We can just say if static clearance, in fact, we can just return static clearance is greater than clearance. That's much nicer. And then, at the point where we're spinning up the environment, as well as calculating clearance, so this is when we're initializing everything, we just need to calculate the static clearance as well. Do I think that's going to work? 50-50. Do I think it's going to throw some sort of exception? Yeah. It's behaving mostly the same, which is good. That's what I would expect. Not entirely sure what this guy's up to. Let's have a look. You're still fine, I assume. You don't have a target node. Are you serious? He wants to go there. It's fair enough. He wants to go there as well. It's fair enough. This node is claimed by Goon. It's fair enough. Not massively sure why that's not his target node anymore. But if you ignore that, the rest of this is arguably fine. So if we nuke this guy, and we reset this to not be claimed by anyone, I said we reset this to not be claimed by anyone. Then this guy is claimed the one below it, and this guy is trying to go there and has claimed it. Oh, that makes sense then. What I don't get is why he's not moved there. No, I do get it. Okay. So the only question left really is why is he clearing his target when he reaches it? Because do we even care? Maybe. And yet maybe not. Mm-hmm. 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 Sure. I'm okay with it. Updated optimal path finding. I think that's all we did. Sure. It's close enough to all we did. Cool. Right. I'm comfortable saying to hell with pathfinding. I think it's good enough until we have a use case. We don't even have a use case for it. Well, we do, but not implemented. I think it's officially good enough. It's pretty great. It handles every single edge case except multiple people arriving at the same spot at the same time. Which I'm okay with for now because we don't even know if that's ever going to be a thing. So, what do we do now? Here's our list. This is everything we used to have. We could add a player. I kind of want to add this stuff. I kind of want to add each node, aka each tile, having stats. I think that could be pretty neat. Maybe if we started off with pressure, because pressure's quite a fun one. Let's do that. Then we can add a vacuum and add the code for it pulling objects toward itself. Which I think will be pretty cool. So, for that, we need to figure out a few things. So, pressure. Because I want vacuums to be able to appear. They're to be like hull breaches, and you get sucked through them, etc. I think that might be pretty neat. But in order to do that, we need each node has a pressure level. Pressure is normalized between neighbors. I think that's it. We would need ceiling, but let's do that for now. Let's do this. Which should be fine. Node. Okay, Nodaroo, you are going to have... We might end up putting this somewhere else, but for now, you have a pressure level, which starts off at 0. Because why not? There we go, that was easy. And then... this is where it gets a bit sketchy. But let's say... equalize pressure. So for this, I'm actually not going to return a void. I'm going to return something else. But for now, we need to... I think we might need an overarching thing that does this. But we have a list of our neighbors, which means we can get all their pressures. And we can say, like, we can look at a neighbor, and we can say... what would we say? We'd say, like, if you're higher than me, I'm going to take some of your pressure. If you're lower than me, I'm going to give you some of my pressure. No, let's just do it one way. Let's just do it one way. If you're lower than me, I'm going to give you some of my pressure. Yeah. A certain amount, which will be defined somewhere. For now, we'll put it here. Pressure change per second equals, I don't know, 1. So, lower pressure neighbors equals neighbors where pressure is less than pressure. So I guess all of our neighbors who've got less pressure than we have. I think I need to think about this a bit more because we want to spread it equally. So I have 1 pressure. I have 3 neighbors who have 0 pressure. I want to give each of them 1/4 pressure. That's the most basic of answers. But I am a guy with pressure. I have 1 neighbor who's got 0 pressure, and I have another who's got 0.5 pressure. Ooh, what do I do in that case? For now, let's go with the noddy solution. It's always a good way. So total nodes equals lower pressure neighbors count plus 1. We'll include ourselves. Or do we... Maybe we sum up the differences and then distribute it vaguely evenly. If I get this right, theoretically we can use it for a lot of stuff. So we get... Let's do a use case, right? I have 1F pressure. Me. 0F pressure. Neighbor 1. 0.5 pressure. Neighbor 2. In this scenario, quite a basic one. If we want to normalize them, then we would say add up the total, divide it by the group, right? So it would be 0.5 each. Which is fine. But I don't know if that's strictly what we want to be doing. We are doing pressure change per second. Also, I'm going to make it an int, not a float. Maybe I won't. I might do. Each tick, this guy would take more than this guy. So let's say I don't know. Do I know? No, I don't know. And admitting that is the first step to overcoming the challenge. There has to be an easy solution, right? Like a legitimate solution. It's such an easy use case as well. So total nodes is 3. I guess we can... Let's just do something mad. It might not be efficient. Yeah. do 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 do. I want to keep, and this is terrible, but we'll see where it goes. Neighbor needs equals new dictionary of node to float. And we're just kind of throwing stuff at the wall here to see what sticks. Neighbor needs add node this dot pressure minus node dot pressure, right? So this gives us in the example, this gives us n1 is 1, n2 is 0.5. Arguably, not much more intel than we had. But then we can say, what can we say? We can say I don't like this one example. Let's change ours to 0.75. So n1 becomes 0.75, n2 becomes 0.25. Don't know why I changed that, but I think I prefer it as an example. We want to give... It's fucked up because we lose pressure as we do it. But I guess we can ignore that for now. We can ignore that for now. So we want to work out what the average would be between them. The final average equals the average of the values. It's not strictly true. Let's add ourself to the neighbor needs. Let's change it to node needs. Now the average will be correct. Hello, Sackboy. YouTube didn't push the stream to recommendations. Oh, the bastards. The utter bastards. You've not missed much. We've been banging our head against the pathfinding. Although I will say it's a lot more stable now. And mildly more efficient. And we fixed the small gap in the wall problem. So the pathfinding is much better now. There's a few issues with when multiple people reach the end of a path, when they're all on the same path. But I'm not too worried about that. Now I'm trying to add pressure. And I'm really getting stun locked. May you see. You can see to an extent. What was our test case before? Let's rebuild the test case from before. Sort of. That was a test case from before, kind of, wasn't it? Let's really go ham on the old opening up nodes. Push it to the limit. Limit! If this doesn't work now, then I'm not going back to fix it. I'm done with pathfinding for today, but it should work. Pretty good, right? It's good, isn't it? Yeah, it is smooth. So, now, I'm trying to add pressure as a mechanic. So I want nodes to normalize, equalize, I guess, pressure between each other. They have access to their neighbors, so it should be doable. But I'm getting totally stun locked on the logic for it. But I feel like I was making progress. Was I? Maybe I wasn't making progress. Cause it's a pain in the ass. But I want it, and I don't just want to ask ChatGPT, even though I could. It'd have some good suggestions. It'd probably give some batshit code, but it'd have some good suggestions. So what I'm trying to figure out is I am a node. I have some neighbors. I'm going to gift some pressure to my neighbors. We're not going to worry about adding pressure. We're purely going to worry about gifting pressure. Yeah, GPT is somewhat good for making boilerplate code. You just can't trust it. You've always got to go, does it actually know what it's doing? Which is fine. And it's good for being a rubber duck. So, I'm trying to figure out how I can distribute a node's pressure to its children in a sane manner. So I'm just writing random shit and seeing what sticks. And so far, nothing's sticking. But I think I was getting somewhere before you distracted me talking about pathfinding. I guess I talked about it, but I'm still blaming you, Sackboy. So, here's our sample scenario. And I'm trying to figure out what logic I should use for figuring out how much to transfer to the neighbors. And that's pretty much it. And I was working out the differences, and then I was working out the average difference. And then I was going to use the average difference for something. I was going to use the average difference to weight how much I give them. Is what I was going to do. But I think I'm leaning towards asking ChatGPT because I'm totally stun locking myself here. And I need inspiration. I feel like weighting them based on the average might be pretty good. But let's see what the old GPT has to say. Hello, friend. Imagine this scenario. There are a collection of 3 nodes. Each of them has a pressure between 1 and 0. The pressure between the nodes needs to equalize over time. That's pretty much it. I'm trying to write a function that for a given node, which knows about its neighbors, will give them a proportionate amount of its own pressure with the goal of them equalizing over time. I'm trying to come up with a method of figuring out which nodes get which amounts, but I'm kinda lost. Help me out! This approach can be visualized as having pipes connecting each node. Yeah, no shit. Don't start doing mathematical models, man. I can't be dealing with that shit. Also, who uses Python? I use Python. Yeah, I know. I guess what I'm really saying is I don't. That's cool, but I'm not a Python guy. Here, let me show you my Unity class. I'm going to delete this, otherwise I'm going to be embarrassed. I know I shouldn't be embarrassed to GPT, but also it'll distract the fuck out of it. I'm also not going to give it all this code. This should ideally equalize with its neighbors. Yeah, I'll just put the whole thing in and then nuke the parts it's not getting. You ain't getting... Wait. You ain't getting this? Mad function. You ain't getting this mad function. Well, it's less mad than it was. We didn't have GPT when making wax. Yeah, that's very true. Nowadays, though, I love it. I love it for inspiration. You don't need to know about the areas. You don't need to know about the awake. You don't need to know about any of that. Hey, look, neighbor's average. I was so close. Average their pressures weighted by a change rate. This will be called once per frame or less frequently, and you can use time delta change. So what's he doing? If there's no neighbors, nothing to do. Very true. Calculate the average pressure of all neighbors. Calculate the pressure difference and update the current node's pressure. So we get the pressure difference between the average. And we adjust the current pressure towards the average pressure of the neighbors. Yeah? That's cool. Sort of. The neighbors will presumably also be calling this update. So they'll all be equalizing with each other. Guess that's fine. One thing I would like, and this is very true, is, and this is probably tricky, a vector showing the direction of pressure change. I.e., if I have a node to my left and I give him pressure, the vector would point left. I think I could use this to apply force based on pressure changes and get some cool environmental effects by applying that force to rigid bodies inside the node. Might be too ambitious, but I want it. Definitely an ambitious idea, but a really cool one. I know, I know. So this time, he's going through the neighbors, and he is working out the pressure difference for each neighbor, and he's getting a vector that points to the neighbor, and he's multiplying the pressure direction by the difference, and he's adding that to the total change. Then he's doing a update, and he is multiplying the pressure direction by the total change, which he's plus equaling the normalized. Okay. Nice. Yoink. I don't know if this is going to work, but I think it would be insanely cool if it does. Dee 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 dee. We're not actually going to worry about applying the force just yet. Let's just kill the goons. Maybe prefab the goons as like a test folder. Hey goon, welcome to prefab land. Cool. And we're going to node render mode. We want one for navigation, one for pressure, and one for none. Da 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 dee 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 dee. Right, now we can set up a different render mode for the pressure stuff. Mm, mm, sure. Cool. So then I'm gonna sneeze. Let's run that. Wait for the inevitable exceptions. No? No pressure. Pick a random node. Pick a node, any node. Set its pressure to 1. I'm something of a scientist myself. Now I'll grant you, it's never slowing down. It's not capping it. We have a very real problem that it's just taking the pressure, right? It's never actually reducing the owner's pressure. Also, the pressure change vector is going insane. But that's pretty rad. Let's simplify this a bit. Two nodes. Okay. Makes sense. Makes sense. Makes sense. Makes sense. Makes sense. Makes sense. Let's make this conditional. Mm. Mm-hmm. And let's update one of these to have some pressure. Pressure difference is -1. Direction is right, which makes sense. Pressure direction is left. We have 1. We're going to be giving it to the guy on the right. The pressure direction should not be left. So we need to swap those around. Total change is 1. Yeah, ChatGPT doesn't know what it's talking about. Total change cannot be the absolute. It can't be. Otherwise, we quickly spiral into infinity. What if it's not the absolute? That's better. That's much better. I need to visualize the change vector. That's pretty cool. But I got rid of the math abs on the total. Otherwise, they just keep feeding each other pressure until they reach infinity. Makes sense, GPT doesn't know what it's doing. Yeah, I agree. It doesn't have All it's doing is guessing the most likely answer based on shit that it's read online, right? You basically need to think of ChatGPT as someone who has watched a lot of coding videos but hasn't actually got any real-world experience. That's the best mindset to have with GPT. It's read a lot, but it's got no practical experience. Now it seems to be working, but I want to add a rendering of the pressure vector influenced by its magnitude, so I can see in real time where it's pointing, etc. Great adjustment on removing that thing I suggested. Yeah, I know. I love it. It's like, wow, well done. You removed that bad code I wrote. Yoink. Right. Let's have a look-see. Let's slow it down a bit. Let's just slow it down just a tad. Just a teensy weensy bit. So, this one is fine. This one is not so fine. So if we think about, I'm going to make these lines a bit thicker if I can. I can't. But I just want it to be thicker. That's not going to make it thicker, but it'll at least make it longer. Which, you know, length versus girth, the eternal debate. So let's give this guy pressure. You see how this one has got that pressure line going out there? They're just going to counteract each other. Like, if we think about these as two rooms, just for the ease of thought. I'm in this room. I increase the pressure in this room. Therefore, it starts pushing through into here. This creates a vector going that way. That makes sense. We can apply that force. Anyone in this room will get pushed this way, right? Makes sense. This one is receiving. So if anything, he should have a vector pointing that way. Like if you imagine you're in this room and a bunch of air comes rushing in, whoom, you're going to get pushed backwards. You're not going to get sucked towards the incoming air. Which means this is where it gets interesting. Our pressure should be going up, which means we come in here, we go, we're going to steal some pressure from our neighbor. Yoink. Which means the direction is going to point to the right. Which isn't massively true. Hang on, let's rename these nodes. Oh, I can't. They're getting created on the fly. What are their names? Node clone and node clone. That really does not help me. Can I give this a name? Should have done that a long time ago, really. Cool. So, let's put a conditional check in here. This dot game object dot name equals node. I can't remember what number it was. Fuck. I think it was -2, 8. Yeah. And this pressure is greater than 0. Cool. So we go, our neighbor's got more pressure than we have. Our direction is pointing towards our neighbor. It's still pointing towards our neighbor. And it's still pointing towards our neighbor. But we don't want it to be pointing towards our neighbor. We want it to be pointing the other way. But if we change any of this, it's going to fuck up the other guy as well. Like, if the pressure difference is greater, i.e., we're stealing his pressure, this should be doing. Hang on. The direction is pointing at him, which is okay. But that means his is pointing at us, which is fine. But his pressure is negative, so his should start pointing the other way. But it doesn't. Why are they both pointing at each other? Like, if we... Let's stop this for a sec. See how they're both pointing at each other? It's not what we want. What if we stop modifying the pressure direction by the difference? Right? Let's just get the normalized vector for now. I expect these to both be pointing at each other. For sure. They should both be pointing at each other. Fosheezy. No doubt in my mind. I'll be honest, I didn't expect that. But it does prove that they're pointing at each other. They're pointing at each other. It's just the length of their line is 10 long, right? So they are pointing at each other, for sure. Otherwise this middle point would not be filled. So if they're pointing at each other, which they are, then why are they still pointing at each other when we multiply by the pressure difference? Because that shit doesn't make any sense. Because we're multiplying by the pressure difference twice. Yeah, that'd do it. Okay. So that is going to flip it to be pointing away, which is cool. But then when we get here, we flip it again. So I think this one does need to be math absolute here. And now I think it's going to be wrong, but it's going to be one step closer to right. I think they're both going to be pointing the wrong way now. But let's see if that's true. They're both pointing the wrong way. Cool. Now they should both be pointing the right way. We want them to be pointing in the direction that we're going to apply the force, right? Based on the pressure differential. Which is exactly what's happening now. So that's pretty cool. Let's increase the size of the arena again. So that we can see those update in real time. Let's go ham on it. Now I'm a little worried about how computationally whack this is going to be. But on the flip side, I think it's going to be so cool that I don't care. Mm-hmm. Moment of truth. Now you might think, oh, that was lame. But it makes a lot of sense. The pressure will be getting spread out between everyone. Which is pretty rad. So what if we dump in... Let's just go crazy with it. Here, do you want to have 100 pressure? I'm pretty sure it's not even designed to work above 1, but... It's pretty cool, right? The pressure is getting offloaded over time. It's spreading out. Now I did limit the pressure flow to be uber low. But I think I would still expect these to be pushing out a bit faster. Maybe I wouldn't. I did really gimp the pressure rate. Let's increase the pressure rate again. Let's bring it up to 0.5. Yeah, it is cool. It's going to be really cool once it starts applying forces to any physical objects that are in the area where the pressure is changing. That's when we can start having hull breaches and everything getting sucked towards them. I mean, dumping 100 pressure into one node is always going to act a little bit weird. But I think it's working fine. It is transferring the pressure. I think I would expect something subtly different. It's hard to quantify what I expect. But I know what I expect, and I know this is not it. I guess we'd need to be fair, we're filling it up. We're not draining it out, right? Maybe we should... What we need to do is we need to instantiate them all with, like, full pressure. And then set one of them up to just consume pressure. Is void. Is it a node in the void? If it is, then do all your shit, but then when you've done it, pressure equals 0. So you do steal the pressure, and you do get forces applied to you, but you're just going to throw it away. And then let's make one node drain the pressure from the level, and let's see what happens. Why are they all red? Of course. Nice. Let's make this guy suddenly become a void, and let's see what happens. I'm going to be honest, I expected him to be consuming a lot more than that. I think the problem is I think it's working fine, but the pressures are all getting... No, they should be fine, right? Because... Look, this guy has got a pressure change vector that's basically nothing. Which is fair, because fair play to him, his pressure is barely changing. But what's happening is, he's dumping his pressure into this guy, which is why he's still got a mad beam, but he's getting refilled by everyone around him. Which isn't translating properly. Because this coming in, so this going out should be giving him a pretty strong vector this way, right? But then these coming in are bringing the total change down. Which is why it was maths absoluting the total change. But I don't think we can do that. We need... Do we need another version of total change that is... Shit, what would it be? It's tricky because if you've got... Let's say you're this node and you've got air coming in from all sides. In that scenario, you would want 0 as your pressure vector, right? Assuming they were providing the same amount of pressure. But let's say you had the issue we've got is that cancelling out. He's giving as much as he's taking. So the vector's getting cancelled. So you would think, don't worry about that. Just do the absolute stuff. But I'm not sure that that works. I think you'd get some really funky behaviors. Because if you maths absolute it, so that it goes, okay, well, there was a shit ton of force in both directions. We're Gucci. That doesn't really work. But I feel like pressure direction what if you just don't normalize it and don't multiply it by the total change? What if you just do that? That's more accurate as to what is happening. Can't tell me that's not cool. That's way more accurate as to what's happening. So now we just need to apply those forces. And then we live in the dream. I will be right back. I'm going to leave this draining. Right. Let's add another node draining, eh? Here, you can be draining. Cool. These little gaps really are quite cool. He's got a kind of normalized vector. Which makes sense. Yeah. I think I was expecting this to... Are these increasing in size? Yes. Okay, good. The power of the vacuum compels you. So that's cool. Now we just need to apply the forces. Which is where it gets a bit awkward, honestly. Because we can't just assume there's a rigid body. But you know what we can do? Mm, mm, mm. This might be horribly inefficient. But, you know, whatever. Who cares about efficiency right now, right? If this is going to be cool, then we can work out efficiency after the fact. Yoink. We did a lot of this stuff in the in the other project. So now, in here, we can say that. And then let's put a goon in there. We're actually going to disable his follower though. Let's make these 4 be voids. I should have increased the drain rate. I should have increased the drain rate. Not sure what happened over here. I mean, he is very heavy. We might need to multiply the force. We almost certainly will need to multiply the force. You'd be hard pressed to convince me that this isn't exceptionally cool though. Right, let's increase the pressure change to 1. And let's multiply the pressure change vector by 2. And we'll make these ones be the voids. Shit, I didn't pause it. Should start picking them up. Okay, 2 might be not be enough. He is really heavy. Although, it is... Well, no. It should be doing more than that. The wind is rushing through, right? Even though the node's pressure isn't changing that much. It should be changing significantly. Like the throughput of pressure is quite a lot. Okay. You win this round. We're going up to 10. That might be excessive. I think 5 would be enough. But fuck it. Wee. Maybe 10 isn't enough. We really need a player at this point so that we can get a feel for it. A feel for how much it's dragging. Let's bring it up to like 20. I know that's excessive, but whatever. Life is excessive. And let's bring the drain rate up to 2. Whew. And let's move him somewhere a bit more interesting. Yeah, let's improve the drain rate up to 4. This one will be interesting because of the holes. How will the holes impact it? Go big or go home? Make a bigger void? Whoa! Maybe I went a bit too mental. Maybe 4 was a bit too much. I think 4 was too much. What's interesting is he seems to be gaining pressure from somewhere. 4 was too much. Even 2 might be too much. It's very much designed to work with 0 and 1. But, you know, whatever. Laser party, yeah, totally. I'm expecting this stuff. I don't know what I'm expecting. I guess I'm expecting... No, I really don't know what I'm expecting. I'm pretty sure I was expecting him to get pulled up here, but in hindsight, I guess I shouldn't have been expecting that really, because he would just get stuck to this, right? Which is exactly what's happening. We would maybe want to implement the ability for objects to clog holes. Not really sure how you'd do that. You'd say... We've got a list of all objects who are in a node, which is super useful intel to have. How would you use that to clog a breach with, for example, a dead guy? This is the perfect use case for it, right? This guy is here. He would ideally stop this node from doing its work. But it also needs to be getting pushed towards this node. Yeah, that might be quite a complicated one to figure out. Clogging the breach mechanic is a bit more complex. Because he is technically clogging the breach now, right? But the air's still going through. Which maybe is fine. It's not really fine though, is it? Not really. Not when there's probably a solution. But what would the solution be? If you just stop that node from feeding you. You've got 5 neighbors. Yeah, that's fair. So I guess you... If you just stop the node that a person is in from interacting with the pressure system, that doesn't really work, does it? Because they'll no longer be getting pushed about. You could make it so if someone is in a node, get this, if someone is in a node, pressure can enter that node, but it can never escape it. It'd be a bit weird. Wouldn't really work. It kind of makes sense. But they'd stop feeding it eventually because the pressure would go too high. This is the perfect use case. This guy, stopping this guy from getting pressure from this guy. Which means that you have to say, this guy cannot give his pressure to anyone. Because you don't know which ones are blockies and non-blockies. But if you say that, these dudes are going to keep giving him pressure. And it's not massively going to make sense. Maybe you, instead of just closing it off, you add a negative multiplier to the air going out, or something like that. Ooh, it's a tricky one. It is a tricky one. Let's run it again. Mainly because I like seeing it. Get the laser show going. So these are pulling in here. That's fine. He gets pulled up to this. Boom. At that point, we would expect the flow rate from here to decrease. That's what we would expect, right? It's just what do we then do with that flow rate? And how do we know that's the case? And how do we ensure that the whoever it is maybe we just don't worry about this use case. But I do think if a node is void and someone lands on it, it should become not void. That could work really well. Then we can have like a hole appear in the floor and everything is getting sucked towards the hole. And you fix it by putting an object on the hole. That could totally work. And then you do like a real repair. So like we say if is void and this dot bodies doesn't have any, do that. That's obviously not the end solution, but it's a good test for it. Then we'll move this guy out of the gauntlet to bring him here. And we will make these be voids. He gets sucked towards it. Well, he plugged one of the holes. He didn't plug them all. Hey, Mr. Tools. It does look cool. He's plugging a few of the holes. But then he leaves one of the holes and he gets sucked back in. Because I think one of the other holes starts sucking him out. Let's make just a single hole. That's the test case I wanted to test. Just a single hole. Let's put it, I don't know, here. He gets sucked in, he gets sucked in, he gets sucked in. There's still a weird light show going on. But why? Are you the void node? You are the void node. Look, I might have made a mistake by clicking on that node. That's interesting, though. So I guess he gets pulled past the node too far. I mean, the forces are ridiculous that we're using. as is the pressure change per second. Let's bring that back down. Look, they're all conglomerating one away from the void, which I don't think makes much sense. Although it kind of does. Because they're getting fueled by the rest of the grid. Whereas these ones aren't. So these ones have only got a limited amount of pushback they can give. So he always gets nudged back off the hole. Which is interesting. These guys rush into the hole faster than these guys, so he gets pushed back off. It's pretty cool, but I don't know how we solve that problem. Hmm. 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 We how would you solve that problem? How would you solve that problem? He's very slowly drifting on the currents of pressure, whilst they fill up this hole in a not very fulfilling way. I think if the hole itself right, when it nukes its own pressure, should arguably suck things towards it. If it's a void, then for each body, um, da 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 da. That is totally YOLO, but it might work. I mean, it might push him away from it. But then we just invert it. Should probably have some sort of magnitude check on that. But whatever. Let's see what happens. I think that's correct. These guys are still dealing with the aftermath. Which is a bit weird, but whatever. Yeah. So then we could have little machines scattered about that will introduce pressure if their pressure is below a certain amount. So we could have a machine like here that says, if my node's pressure is below whatever, then you know, add some more pressure into the mix. And then that could be cool. Also, look, it is normalizing. I think it's just a pressure flow rate we'll need to tweak. But the average pressure of the entire thing is now going to be down. I don't know why clicking a node makes everything freak out. I think it's because it lags the system, so the time span changes freak it out. And it does something in a massive amount. But every time I select a node or something, see, it modifies everything. I think that's because it's skipping a few frames. And then it massively overcompensates. But that's not a real problem. Well, it might be. But, you know, whatever. Then if we move him again, the void is opened up. He gets sucked in. And it all tries to equalize. Cool. Kind of cool. Sort of cool. Pretty damn cool, I think. Yeah, I think it's cool. So then we can add a machine that refills the pressure. Let's do that. Pressure machine. Maybe we can have it so that you can set a target pressure on it. Just for shits and giggles. I don't know why you ever would, but maybe you could. If you wanted an area to be a vacuum, you could set its target pressure to be 0. I don't know. Be a bit weird, but so this would be machines. It'd be a machine. Let's do machines for now. I was going to just say objects, but I overused the word objects. Let's say machines, and let's add one. And then this is something that could fail, and you have to fix it up. So, the pressure machine we need to steal something from Path Follower. Do we? No. Pressure machine. You need you're gonna have access to a node. And your node is going to be your whatever, it's just a node, who cares? Target pressure. If node is null, you ain't doing shit. Otherwise, if node dot pressure is less than target pressure, node pressure add I don't know. Pressure change per second equals 0.1. There we go. If node dot pressure is greater than target pressure, node pressure minus equals pressure change per second times time delta time. This is an exceptionally lazy way of doing this, but node dot pressure equals mathf dot max node dot pressure target pressure min. Cool. Nice and simple. not too computationally expensive. Let's give him a sprite. For now, it's going to be... let's also give him pressure machine. His sprite is going to be... Who particularly cares? I'll be right back. Imagine, if you will, a pressure machine with a robot core who is very unhelpful and just keeps draining the pressure from the ship. That'd be pretty great. He doesn't really need a sprite, honestly. Sure. I'm eating a cookie. Cool. So now wherever we put him, he's gonna try and get the node for that spot. And indeed he has. Very cool. So he's got that node, I assume. Yeah. Nice. Just for shits and giggles, Let's increase the target pressure to 100. Now stuff will get blown away from him. Speaking of stuff getting blown away, I hope you guys are suitably blown away with how great this is. Let's set it to 0. Let's change pressure change to 1. Now he's essentially a void, right? He's stealing all of the pressure. Pretty neat. Good, Sackboy. Good to hear it. And this poor guy got launched into the ether. But that's fine. So that works. Pretty cool. So now let's make a void here. He's plugged it with his body. I like the idea of plugging holes in the ship with corpses. And he should be feeding the ship. I'm not really sure why he's drawing 2 lines. That's kind of mental. He's drawing a lot of lines. Best not to worry about it, I suppose. So now he should be feeding the rest of the ship. Not very effectively, but he should be. Until the pressure comes back up. And normalizes. Which is pretty cool. Increase his rate of normalization. He's totally firing it out. And we're just going to leave it here for a sec. I want to see the pressure normalize. We know that it should. I want to see it happen. And that is pretty cool. So now we've got pathfinding. We've got a pressure system where we can introduce voids. We're not going to keep that plugging the gap mechanic, but it'll be similar. We can introduce pressure differentials and apply physics based on the airflow which I think is pretty sick. So here, buddy, do you want to go for a walk? Oh, he's trying. He's trying. He escaped. The madman did it. He doomed the ship so that he could go to 4-4. And then he gets pulled away by the airflow. And then he goes, wait a minute, I'm not at 4-4 anymore. And he goes back. Good job, buddy. This guy's fighting a losing battle, repressurizing the ship. These vectors are growing. They should be growing. He's going to get caught up in the currents. Swept down here. Plug the gap. Live the dream. He's going to save the ship even though I've disabled him. Let's speed it up a bit though, eh? I do want to see him navigate this corner. He's going to get sucked round the corner by the airflow. He's driftwood floating over water. Do 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 do. Uh? Into the hole. You did it! You saved the ship! There is a god. And then we've got the holy shining beacon of the pressure machine, who's really doing his best to restore pressure. I don't mean to toot my own horn, but I bet when I said I want to add an atmosphere to each tile. I bet you guys never thought it'd be this cool. Not in a million years did you think it'd be this cool. And I'm saying that because I didn't think it'd be this cool. But here we are with an incredibly cool mechanic. He is getting pushed away by the increased pressure, which I don't know if that should strictly be happening. He must really be blasting out that pressure. We might want to make pulling be more powerful than pushing. I don't know though. I feel like it doesn't make a lot of sense. But he should still be getting sucked towards the void. I find it hard to believe that the pressure machine is overpowering the void suckage. But it seems to be. Maybe it's not. Maybe it normalized. He's doing quite a good job of refilling it. Quite a good job. And now I'm going to ruin all his progress. Hey Goon, do you want to go for a walk again? Very satisfying. You know what else is very satisfying? That the air coming in and the air getting sucked out cause these kind of weather patterns. It's pretty neat. I'm not sure what we do now. We could make a real sprite for the pressure machine. I feel like we're not quite at that point yet. I could actually think about how blocking holes works. The current way of doing it may be fine. It does work. It's relatively clean. Let's really fuck things up. Let's add another void. My god! We're doomed! Here, do you want to go for a walk? Uh. What I'm really pleased about with this is how it interacts with the walls. It's really nice. It's really, really nice. But anyway, enough tooting my own horn, even if it is well deserved. I'm pretty sure we're running out of pressure. If the pressure is going up, it should display a green light. Can I even do that? Maybe. No, not really. Yeah, whatever. It's not really the purpose of this thing. Let's make it a different color, though. Let's make it blue. And then we need to figure out what we're doing next. So we'll have to take a look at our list. Which is cool. Will he get sucked through that door? I think he will. Nice. I think we can use this for other stuff as well, you know? Water. Gases. Toxic gases. Water is a good one. And I'm only saying that because it's blue now, but it would kind of work for water, wouldn't it? Yeah, it totally would. Cool. You know, we should maybe think about rendering the airflow. Because if the nodes aren't turned on and the debug lines aren't turned on, you kind of want to be able to see it, right? I think the way we'd do that is we can make each node have a sprite that we rotate in the direction of the pressure vector, and we alpha it based on the magnitude of the pressure vector. That'll be pretty simplistic, but it'll be a good jumping off point to see kind of how it looks. So, what would it look like though? We'd kind of want it to be animated, eh? Shit, man, that means I've got to go into Photoshop. I suck at Photoshop. Oh. Let's go into our Giga file. This is the size of a node. So let's create a new layer. And I honestly don't know what I'm doing here. I'm just going to YOLO something and see how it looks. This is going to look gash. But that's okay. But if it was animated, just imagine it was animated. But for now, it's not. This is going to be a turd. We're going to call this flows. Airflow. This is going to look so terrible. Tray to replay. I need my little thing back for modifying all these. My little button. I tire of doing it myself. The center for this needs to be 1616. Which just goes to show. Does it need to be 1616? No. How wide is it? 20. It's 20 wide. 12? It's 26 high. Where the hell did I get 12 from? Well, let's assume 12 was right. I don't think it makes sense. We need this to be the center of the 32 by 32 that it's sitting in. So it's 20 wide, which means it has to have 6 on either side. Am I just being really dumb? I think I can just do it as center. I was just being really dumb. Cool. Now, just to clarify, we know this is going to look dog shit. Where are you, nodes? You're in environment. Node, you need to have a sprite called pressure sprite. Sure, why not? Okay, node. Enjoy your pressure sprite. And when you wake up, if render mode equals none, this sprite renderer sprite equals pressure sprite. This sprite renderer color. How do I set the alpha? Fine. Don't do that to me. That's how it is, huh? Okay, you asked for this. Hello, friend, I am back. And my pressure shiz is awesome. Now I've got an uber basic problem. Namely, what is it? I want to set the alpha on a sprite during runtime. I thought I could just do sprite renderer dot color dot a equals whatever, but I can't. Help a brother out. You have to create a new color object. Ah, that is so jank. That's exactly what I was hoping I didn't have to do. I love how it's like, why don't you make a component for doing it? No. Last resort is GPT, yeah. I am actually going to make a function for it in utilities. Color extensions. I don't know why they couldn't do this by default, but F them. Not doing yourself any favors. Is that a float? Yeah. The alpha and the omega. Right. Well played, Unity. Turns out you do have it by default. Thank you very much. Right, cool. So then, sure. I don't know what I can expect from a pressure magnitude. Let's just go with 1 for now. If this dot render mode equals none, which I know is mental, but whatever. This sprite renderer color equals this sprite renderer color with alpha ratio. And then we need to rotate. Do I really want to rotate the entire node? Does it matter? No. Maybe. No. this sprite, this transform look at can I not just give it a vector? No, but don't mind if I do. Right. Let's set the render mode to be none. Now, just so you're aware, never forget, this is almost certainly going to look dog shit. You sly devil. As I was saying, this is almost certainly going to look dog shit. But that's okay. If it was a bit more subtle and animated, bit more subtle and animated, maybe not pure white. So if we animate it to be like flowing, in the direction, then maybe, just maybe, it just might work. Because it is showing the airflow, but you can't tell which direction it's going, right? don't do that. Fine. Now, if we were going to animate this, we probably need a reasonable amount of frames. Could not nudge because of a program error. Well, I appreciate that, Photoshop. Um, five. 32 divided by 8 is 4. I know it's an obvious statement. Uh, dee 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 dee. Dee 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 dee. Mm-hmm. One frame down. This blows. This really blows. I bet you can do something clever with this. Like set it to tiling and change the ratio or something. Set it to tiling and change the reference point in the sprite renderer. I bet you can do that. Well, look, I bet you can do that. I bet it's possible. Let's do the old GPT. I have a sprite which I want to blow. Namely, I want to have it animate by moving upwards and having the top appear at the bottom. That is a terrible description of what I want. But you know what I mean. Maybe. Anyway, instead of making like 8 sprites for it, I figure there's probably some clever way to do it in the sprite renderer by changing the starting point of the sprite to draw from and setting it to be tiled or something. Am I right? Seamless looping effect, correct. You don't need multiple sprites, you can achieve it by manipulating the texture offset. Boom! There we go. I thought so. I don't like that he's looking at materials. But I guess it's fair. This may be a bit too much. Every single node having its own material might be excessive. But on the flip side, whatever. What are the odds that this looks like trash? Pretty high. But we can probably change the scroll speed based on the pressure change. And that'll make it look even cooler. What? Unity, you've quite literally never asked me for consent. Unity, you are an odd fellow. I especially like how you just nuked some of my changes for no reason. To be fair, I did tell it could. Where are you? This class is doing too much. This might be too mental. We might need to tone this down. But let's see how it is. It's certainly doing some weird ass shit. There's definitely something odd going on here. For starters, my alpha doesn't seem to be working anymore. Secondly, well, that's the main thing. Why is it modding that to 1? Oh, I know why it's modding that to 1. Does it need to mod that to 1F? I still don't know why my alpha's not working. Maybe it's to do with the material change. 'Cause we are living with a material change. Na 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 na. Hmm. If we can get the animation working, then we can deal with the alpha problem. But there isn't an alpha problem, look. But as soon as you set this bad boy to be a void, fair enough. I guess that really did have to be time. But I don't trust that. If you've got a scroll speed of 1, then on second 1, it's going to be 1. On second 2, it's going to be 2. Yeah. But if you've got a scroll speed of 0.5, on second 1, it's going to be 2. On second 2, it's going to be 3. I don't mean to tell. The old GPT its business, but I'm pretty sure that should be divide. I want to believe. The alpha's vanished again. The alpha's vanished, and it's not. I see how it is. Okay. How about, what if you really are just 0.5f? I don't really get why the alpha would vanish. You know, it's almost correct in a backwards kind of way. In a backwards slash not repeating kind of way. It's almost correct. What if I do that? Um, that's close to being correct. Partially. They shouldn't be going into those corners. This stuff is correctish, which is arguably what counts. This stuff is potentially correct. If the alpha was working, the alpha and the omega, the anthem dot trademark, yeah. If the alpha was working, this would be alright. I think it is doing what it should be doing. So let's set this back to scroll speed, which is going to make it look a bit weird. But that's okay. There's definitely something jank as soon as I do scroll speed, eh? I guess the pressure direction slash magnitude is significantly higher than 1. I don't know, 5? We're just going to test some values in this, see which one sticks. I think even 5 might be too low. Yep. Which is weird. Um, 20? If in doubt, trial and error. It's pretty good. $20 was maybe a bit much. Although it is nice and subtle. Hmm. 10. I think scroll speed's the next thing we're going to have to tweak. Hmm. Do 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 do. Dee 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 dee. Pum 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 pum. Gonna be honest, I feel like I made it worse. Why don't I just do the same thing? And probably shouldn't put this here, but whatever. Will it let me modify that in the editor? Tell me why I can't modify statics. You turd. Does this really belong in the environment? No. Arguably, they should be... That's an odd name for it to suggest for a class. Bum 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 ba bum bum bum. Da 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 da. Should have done this a while back, really. Sure. And then we just need to create an object, slam that global config thing on it, which I should have put in its own class first. Its own file. And then we can just tweak them in real time without having to worry about shit. Right, let's find some values that make vague sense. You know, in a lot of ways, I feel like this isn't making the slightest bit of difference. This one is, which is cool. Which means my whacked up, weird ass thing here is probably not right. That probably does need to be times. That makes literally no sense. Why? Why have they all suddenly got like billions of pressure? Trillions of pressure? Why have they suddenly got trillions of pressure? Why? It doesn't make a massive amount of sense. All I did was click on a node. That node was always on my mind. That node was always on my mind. Like, I get that we multiply it by time delta time. I get that. But in a lot of other ways, I really don't get it. It's like one of them is just getting the most insane pressure known to man. And that's causing that to bubble out across the entire group. Which is annoying. Because I can't think why they would do it. Like, I would get it mildly spiking. But not this much. Not like this. Why have you got minus 400 pressure? Surely! Yeah, there is no surely. Pressure equals pressure math F max. I don't like doing this, but whatever. Let's at least stop it going into the negatives. What would negative pressure even mean? I don't know, but I feel like it should never reach it. No, it definitely could reach it. Very easily. But it should get offset pretty quickly afterwards. But now that we're capping it to 0, I don't expect that to fix our problems. But whatever. You know, in a lot of ways, it really did fix our problems. I miss the days when it was just a ray I was casting. Those were the days. Mm. 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 I'm not massively sure why it just behaved the way it did. I think it's got something to do with the insane magnitude change. It doesn't know what it's doing here. That's because this is pumping air in whilst air's getting fired out, but this isn't pumping it out very effectively. I think it's safe to say we may need some tweaking on the old graphical representation. We may need a little bit of tweaking on the graphical representation. But lest we forget how cool this is, let's just ignore the graphical representation for now. Let's go back to the laser party. And then we can ponder what we can actually do with this. Laser party, ho! There's some weird vectors happening in this laser party. But maybe they do make sense. Hmm. Yeah, maybe they make sense. Hmm. 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 It's weird that he's not joining in. Oh, he's probably cancelling out on either side. He's probably giving to both sides, which is cancelling out his force. Yeah, I think this is correct. Let's get this guy caught up in the flow again. Alright, sorry. Let's get this guy caught up in the flow again. Oh, he scuffed his edges. There is no God. Okay, Goon, it's your mission to plug the gap. With the sheer weight of your body. I think this is working correctly. The rendering is naff, but who cares about that? And well, that's it really. The rendering is naff. I think apart from that, it's fine. Yeah. Yeah. Cool. So yeah, I'm not sure what we had next. We've added our little machine for restabilizing the pressure. I don't know. Je ne know. Let's have a look at our list. I was going to add temperature, but I don't know what we'd do with temperature. I think oxygen level is just going to be pressure. I think that's fair. And if we want to be able to start fires and shit, I mean, temperature we do want so that if you can find like a cold room, maybe you could put caskets in there temporarily. Maybe. I don't really know on that one. We could add the player. The player wouldn't really serve a purpose other than existing, which is a purpose, I suppose. I don't really consider it one, but it could be. Is there any other environmental stuff? High-level environmental stuff that I want. So we've got pathfinding. We've got the atmosphere. Is there any other high-level, overarching mechanic that I want? That is the question. And I feel like the answer to that is... maybe. 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 Wonder if we should increase the flow rate on the nodes. I feel like 0.5 is really gimping them. To be fair, it's at 2, so I don't know what I'm talking about. Remember when I increased it to 4 and it exploded? I want to try that again. I feel like it doesn't drain fast enough. I know it's only an individual hole, but still. I feel like even with an individual hole, it should drain pretty damn fast if it's not plugged. I'm no scientist, but I feel like that's true. Let's go 716. Yeah. 4 really is too much. 4 nukes the entire grid instantly. And then fills it again? What? It's this guy. It's this little bastard. Sort of. But why? He's flooding the realm with pressure. Or someone is. And it's causing a resonance cascade. Both negatively and positively. There's no way this would cause the resonance cascade. Which means it has to be, and probably is, the far more mental stuff going on in here. Hang on. So this is the pressure difference. Let's think about this for a sec. This is the difference. So we get a vector between the nodes, that's fine. We normalize the direction, and we weight it by the pressure difference, which is fine to an extent. However, the pressure difference isn't enough for us to know that, because we've got that cap. That's the most we're allowed to take. I wish sometimes it wouldn't suggest nonsense, because I sit there analysing the nonsense that the IntelliSense has suggested. And it's like, at some point, you just got to move on and go, no, that makes no sense. Yeah, real pressure change. Because there's a flow limiter, right? And that just becomes total change. I think then it should never go into the negatives, but why risk it? Do I want to multiply the vector by time delta time? It's going to uber shrink it. It's going to shrink it more than we could ever believe. Not for now. Fuck it, let's just see what this does. I feel like that should be more stable. But it might not be. But it should be. It really should be. I'm hoping it avoids those issues where it totally spikes when I select a node. That's what I'm hoping for. You know, if there's one thing I didn't expect, it was the laser light show. to be fair. I have still got that at 4, but that should be okay. I should be allowed to have that at 4. Let's bring it back down to 1. But I should be allowed to have that at 4. It should work. We're still getting the laser light show. What's interesting about this is pressure is 0. Across the entire grid. Well, not the entire grid, but definitely most of the grid. Which shouldn't be happening. Which can only mean I've done goofed. How is pressure dying? How is pressure dying? So we get the pressure difference. This is the most pressure can change for this frame. So we say, okay, let's get how much we can change the pressure for this neighbor, this frame. And we add that to our total change. Which is cool. And then we add that frame limited value to ourself. So why does the entire grid die instantaneously? I mean, there is an obvious answer, which is I've got pressure change per second to be 1. But I feel like it was changing in less than a second. The entire thing just gets insta-gibbed. There's no... The entire thing's just getting insta-gibbed. This guy's churning out little bits of pressure, which is cool. The only thing I can think of is... You know, it's super weird that we don't actually take the pressure from our neighbors. That's really bizarre. But maybe it makes sense. Otherwise, we're all going to be taking each other's pressure. No, it doesn't make sense. You're going to get pressure appearing out of thin air. What if we say neighbor dot pressure minus equals real pressure change? Fuck it. Let's see what happens. Let's see what happens. I feel like I had it working fine, but that it was actually kind of messed up. Should have probably at least committed what we had, though. Gotta be honest, I didn't expect that. That's a new one. Out of all the things I expected, this didn't really come into it. Not really. This doesn't even make sense. What? I feel like pressure change per second. is just going loco. I think we might need to go back to the 2-node situation. Because this doesn't make sense. My neighbor has 1 pressure. I have 0. Pressure difference is 1. The maximum change is whatever, some small number. So the real pressure change is that small number. So we take that small number off our neighbor, and we add that small number to our total change. And we update our pressure by that small number. And that's all we do. And then our friend comes around. He's got us as a neighbor. His pressure difference is negative, which means this fucks up. Or this fucks up, rather. But it still fucks up to a small number. But it does fuck up. So, let's fix this. The only way I know how. Lazily. That solves that problem. Let's see what impact that had. I see. But why? Oh. Yeah, that'd do it. Whoops. I'm 7 hours in. That's my excuse. And it's a pretty damn good one if you ask me. Let's go with 714. He's a good node. He's in the middle of nowhere. Okay. Tiny numbers. Tiny numbers. Do 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 do. But I'll take tiny numbers over giant numbers any day of the week. So now what happens if we bring pressure change per second back up? Like a madman. Then it goes mental. It's actually hard to say whether it goes mental, but I certainly feel like they shouldn't be gaining pressure. He's not gaining it or losing it. He's living the dream. These guys have created like an enclave of stealing everyone else's pressure. It's finally breaking down. But you know what? I think that goes to explain why they weren't doing that. But I don't know if I really believe that. Because there's going to be ghost pressure. Sweet, sweet ghost pressure. Hmm. That's that ghost pressure kicking in. Okay, here's what we do. We undo all that weird shit I just did. And we go back to when it was actually working. Except for the unstable frame rate issues. Because, you know, back in those days, it at least worked. And then I can commit that. And then we can start dicking about in the safety that we know we've got a version that works for the most part. Let's mix things up a bit. Let's have him be a void. Right, it's back to working. Which is cool. So we just need to figure out the old clicker node and sometimes it spazzes out problem. Where's he going to end up? Will he get sucked into the void or will he get sucked into one of these holes? Yeah, the hole got him, but he's getting pushed out. Will he make it to the next one? I personally don't think so. I think he's going to get stuck there. Which is fine. I would like to add in the whole he can block an entrance thing. I think it'd be pretty good. He's totally getting sucked into that void. We want to make it pretty aggressive. Currently it's quite laid back. He's plugged the void. He's the hero we need, but not the one we deserve. Nice. Now he's repopulating the pressure. We're back in the land of good. Awesome. But you see how it kind of janks out every time I select something? This guy wiggles. That's just time delta time kicking in. But it's kind of bizarre, isn't it? Cool. Right. Let's commit that because we know it works. Even if it is a bit unstable. Added pressure system where pressure equalizes and dynamic objects get pushed where the pressure differences take them. Cool. This, while it works, I think it does have that ghost pressure problem. So we'll need to fix that. But look at it this way. Yesterday, we did navigation. We mostly got it working. There was a few little quirks. We fixed those at the start of the stream. All was good. Today, we've decided to do this pressure system. We've almost got it working. There's a few little quirks. Tomorrow, we can fix these little quirks and then get something else almost working with a few little quirks. It's a good routine, I think. So, we're going to call it there. But first, I don't know why taking that to 4 breaks it, but 2 doesn't. Let's just try 2 again, make sure. 2's what we used to have it on. You are the void. See how he completely tanked that entire area? He didn't tank the entire grid, which is good. But he certainly did tank the entire open area. I think it's to do with neighbors. I think with the implementation we have, the more neighbors something has, the faster it gets tanked, which does make a lot of sense. So maybe it's correct? It's just very fast. It tanks it like halfway. Well, no, actually. It tanks it all the way, but he's blocking it now. What? We've got the ghost pressure problem. Pressure will now infinitely climb. Is it every time I click on the guy? Because it was fine when I was selecting different nodes, but as soon as I clicked on the goon, it exploded. Which doesn't make a lot of sense. I think it's just fragile when it comes to time delta time. Yeah, it really nukes that fast. It's time delta time issues for sure. So we'll fix those tomorrow. I am going to go to bed. I have work in the morning. It's been a good one. Very productive. Hope you guys enjoyed it. I certainly did. Enjoy the rest of your nights. And I'll catch you guys later. Adios.